So the enthalpy of a reaction, what is the enthalpy of reaction? This quantify delta H of reaction, Rx in subscript shows the about the reaction, is called the enthalpy of a reaction or heat of the reaction. So whenever we do any chemical reaction, basically some heat, either it come out or it takes, so that heat is represented or expressed in the form of enthalpy of a reaction, and that is symbolized like delta H of reaction. For an example, here two molecules of hydrogen gas when react with one molecule or 1 mole, I will say 2 mole of hydrogen gas when react with 1 mole of oxygen gas, they form 2 moles of water, and this is shown in this figure that this balloon is filled with the hydrogen gas, and when we ignite with the candle, so hydrogen gas use atmospheric oxygen gas to react violently, and it produced water gas, basically water vapor, and explosion happen. So basically this is kind of exothermic reaction where the final product have less energy compared to hydrogen and oxygen, and that shows by this graph that hydrogen and oxygen gases have higher energy. When they react, they remove their energy, so energy is or enthalpy or heat is coming from the system to the surrounding. So that is why delta H will be less than 0 or negative, and this reaction will be called exothermic reaction. So the heat of reaction, heat of enthalpy of the reaction is the enthalpy of reaction is, or heat of reaction, it shows that if this reaction require heat or it produce heat during the reaction. So next example we'll see. The change in enthalpy delta H is the enthalpy of a product minus enthalpy of the reactant, which we have seen in earlier slides. And when we talk about this chemical reaction with the methane gas, when burned or combust, it produces carbon dioxide gas and water. So when it react methane gas burn, then it is kind of exothermic reaction. That is why delta H is minus kilojoule, minus 890 kilojoule. Kj is represent for kilo and J for joule, because heat is the unit of heat is joule. And the inverse of this reaction means if you want to combine carbon dioxide gas and water molecule to produce back methane gas and oxygen gas, you have to give this much energy. So that will be kind of endothermic reaction, and the delta H will be positive 890 kilojoule. So enthalpy of a reaction means when a reaction works, does it produce the heat or does it takes the heat? So that information is come from the enthalpy of reaction. Next is a helpful guideline about the enthalpy. Enthalpy is an extensive property which we have seen and studied in our previous videos and slides that depend on the amount of material. So let's take an example for this methane gas burning. When methane gas burn or combust, this is a combustion of methane gas, it produces carbon dioxide gas and water molecules, and it is an exothermic reaction because delta H is a minus, and it is producing 802 kilojoule of heat. but when we take 2 moles of, so this above reaction shows for 1 mole of methane gas, and if we are taking 2 mole of methane gas, the amount of energy will also produce just double in quantity. So that shows that enthalpy is an extensive property. If we are taking amount double, energy will also come in the form of double, or if you are taking amount half, energy will reduces to half. So this was one property of enthalpy for the reaction, and another one is enthalpy change for a reaction is equal in magnitude but opposite in sign to the enthalpy change for a reverse reaction. So this we have seen in the previous slide, that when methane gas burned, 1 mole of methane gas burned to produce 1 mole of carbon dioxide and 2 mole of water molecules, it produces 802 kilojoule. But when we go back, basically this reaction shows that when we combine carbon dioxide gas and water molecule to produce methane and oxygen, the sign of enthalpy will change. Basically it would be, so this will be exothermic reaction, and the reverse of this reaction will be endothermic reaction. So endothermic means now you have to give this much energy to these molecules to produce the methane and oxygen gas. So enthalpy is extensive property, and enthalpy will change the sign for the reverse reaction. These are the two important parameters you have to remember. And third one is the enthalpy change for a reaction depend on the state of reactants and the products. So if the state will change for like solid to liquid or liquid to gases, the enthalpy will also change. So enthalpy is also a state function, and let's see one example. Calculate the quantity of heat produced when 2.5 gram of ammonium nitrate decomposes at constant pressure. So in this question you can see that 1 mole of ammonium nitrate solid, when decomposes, it produces 1 mole of N2O gas and 2 mole of water, and it produces minus 37 kilojoule of energy. This is also an exothermic reaction. And now they are saying how much the quantity of heat will produce when we will take 2.5 gram of ammonium nitrate. So what we have to do, so in this case you can see that if this reaction has a coefficient nothing, it means the coefficient is 1. So this shows that 1 mole of ammonium nitrate decomposes, it produces minus 37.1 kilojoule of energy. So now we have to find out how many moles will be in 2.5 gram of ammonium nitrate, and then accordingly we can calculate the enthalpy of this reaction. So I have solved this problem, and then let's check how to do this one. So first we have to convert 2.5 gram into number of moles. So number of moles, how we will find out? Number of moles, small n, is equal to small w upon molar mass. So molar mass of ammonium nitrate will be calculated like 1 nitrogen multiplied by 40 plus 1, and basically there are 2 nitrogens, so 40 plus 40, 14 plus 14, and then 4 hydrogen plus 4, and then oxygen 3, so 16 multiplied by 3, 48. So total molar mass will be 80 gram per mole. So 80 gram per mole will be molar mass of this ammonium nitrate. So now we know the molar mass, and now we know that 2.5 gram of amount we have. So how much mole will be? So number of mole will equal to 2.5 gram divided by 80 gram per mole. So gram will be cancel out, and then once you will calculate this one, the number of mole will come 0.031 mole. So 2.5 gram of ammonium nitrate is equal to 0.0313 moles. So now we know that in the question they are talking about 0.0313 mole ammonium nitrate will produce how much energy or how much enthalpy. So now we can utilize the dimensional analysis type this solve question. So we have to use a desired unit on the top and given unit at the bottom, so which is 1 mole. So you can see for 1 mole we know that the energy or delta H for this reaction is minus 37.0 kilojoule, and for 0.0313 mole of ammonium nitrate will how much? So we can cancel out these two units and ammonium nitrate, and once you will multiply minus 337.0 multiplied by 0.0313, the answer will come minus 1.16 kilojoule. So you have to report your delta H or enthalpy of reaction in with sign. If you forgot the sign, then answer will be incorrect. So always use this sign also. So let's solve. Let's see the another example. Calculate the quantity of the heat produced when 0.345 mole of oxygen is formed at constant pressure. So this reaction is given potassium chlorate. When decomposes, it produces potassium chloride and oxygen gas, and you can see they are talking about the oxygen. So we have to consider only oxygen and enthalpy. So when 3 moles of oxygen gas produced, then enthalpy of reaction is minus 84.4 kilojoule. Now they are talking about 0.345 mole. So how much enthalpy of reaction would be? So let's see how we can solve this question. This is basically very easy. We know that number of moles, 3 mole will produce minus 89.4 kilojoule, and then use the dimensional analysis way, desired unit on the top and given unit at the bottom. So they have given 0.045 mole of oxygen and then multiplied by minus 89.4 kilojoule divided by 3 mole, because you can see this coefficient is here 3 for this reaction. So we have to use the 3 mole. So 3 will mole will be cancelled out, and once you will calculate, just you have to multiply this 0.345 multiplied by minus 89.4 divided by 3, answer will come minus 10.281 kilojoule. So this is the way you can calculate enthalpy of a reaction with different amount if you know the standard reaction and standard enthalpy. So we will see other example in the next video and practice problems.